In this video, we shall learn about different types of sets. First, let us see the definition of sets. A set is a well-defined collection of objects. A set is a well-defined collection of objects. That is, we will be clear whether an element belongs to a set or not by seeing the definition of the set. So, a set is a well-defined collection of objects. The objects in the set are called elements or members of the set. The objects in the set are called the elements or members of the set. Usually, a set is denoted by the capital letters of the English alphabet. If A is an element of the set capital A, then we write as A epsilon capital A. We read it as A is an element of the set capital A. Now we shall see methods of describing a set. There are mainly two methods for describing a set. The first one is rule method, which is also known as selector method or property builder method. In this method, we state some properties satisfied by the members of the set. So, by seeing the properties satisfied by the members, we can clearly understand whether a member belongs to a set or not. So, in rule method, we state properties satisfied by the members of the set, but we do not mention which are the members of the set. For example, consider the set A defined as set of all x such that x is an element of n x less than or equal to 4. Here the letter capital N refers to the set of natural numbers. So in this definition of the set A, they are mentioning that the elements of set A are natural numbers which are less than or equal to 4. The elements of set A are natural numbers less than or equal to 4. The next example, x set of all x such that x is a student of 5th sem BA economics class. So, if a student does not belong to the 5th sem BA economics class, that student does not belong to the set A. So, the set A is well defined. Next example is set of all x such that x is an English alphabet. So, all the letters in English alphabet are elements of the set A. The next method of representing a set is tabular method or roster method or enumeration method. In this method, we list out its members. For example, A equal to set 1, 2, 3, 4. That is, the elements of the set A are natural numbers which are less than or equal to 4. The difference is that we list out its members. Another example is set A, B, C, etc. up to Z. Here again, the elements of set A are members of English alphabet. But in this example, we list out the members of the set A, while in the earlier slide, we only mentioned the properties satisfied by the members of the set A. In the next example, the members of the set A are vowels A, E, I, O, U. Since the set is represented by tabular method, we list out its members. Next is types. First, let us see what is a finite and infinite set. A set is said to be finite if it contains only a finite number of elements. A set is said to be finite if it contains only a finite number of elements. For example, A equal to set A, B, C. This is a finite set because it contains only 3 elements. A set is said to be infinite if it is not finite. A set is said to be infinite if that set is not finite. For example, A equal to set 1, 2, 3, etc. Here the members of the set A are listed out, but the number of elements of set A is not finite. Next is set B. B equal to set of all x such that x belongs to R, 0 less than or equal to x less than or equal to 1. Here R denotes the set of real numbers. So we are not able to list out the members of set B, and the number of elements of set B is not finite. So B is an infinite set. Equal and equivalent sets. Two sets A and B are said to be equal if they have the same members. Two sets A and B are said to be equal if they have the same members. For example, A equal to set P, Q, R, S, B equal to set R, P, S, Q. We can see that the members of A and B are same. So they are equal sets. Then two sets A and B are said to be equivalent if they have the same number of elements. For example, A equal to set A, B, C, D. B equal to set 1, 2, 3, 4. We can see that the members of sets A and B are not same, but they have the same number of elements. So A and B are equivalent sets. Null set and singleton set. A set which contains no elements is called null set or empty set. A set which contains no element is called null set or empty set. It is usually denoted by an empty flower bracket or the Greek letter phi. It may be noted that set 0 does not denote a null set because it is a set which contains the element 0. So it is not a null set. A null set is a set which contains no elements. Singleton set or unit set is a set which contains only one element. For example, set 3 contains only one element. Again, example set 0. This is a singleton set, not null set. Next is subset and superset. If every element of a set A is also an element of set B, then A is called a subset of B. If every element of a set A is also an element of set B, then A is called a subset of B. For example, A equal to set 1, 2, 3 and B equal to set 1, 2, 3, 4, 5, 6, 7. Then we can see that every element of A, namely 1, 2 and 3 are also elements of B. So, A is a subset of B. Few properties of subset are: every set is a subset of itself. Every set is a subset of itself. Null set is a subset of every set. If a set has n elements, then it has 2 raised to n subsets. If a set has n elements, then it has 2 raised to n subsets. Superset. If A is a subset of B, then B is the superset of A. If A is a subset of B, then B is a superset of A. Next is power set and universal set. The set of all subsets of A is called the power set of A. The set of all subsets of A is called the power set of A. For example, let us consider the set A equal to set A, B, C. When we consider the power set of A, we have to write down all the subsets of the set A. We have already seen that null set is a subset of every set. Null set is a subset of every set. And every set is a subset of itself. So when we write the power set of A, we can see that we have to include the null set phi and the set A, that is the set ABC. Now this set A has 3 elements. So the power set has 2 raised to 3 elements. If A has n elements, then the power set of A has 2 raised to n elements. In the given example, A has 3 elements. That means the power set of A has 2 raised to 3 elements. That is 8 elements. Universal set. Universal set is the set containing all the sets under consideration. For example, in this example, we have 3 sets A, B, C which are under consideration. We have 3 sets A, B, C which are under consideration. Then U, here U, the set U contains all the elements of the 3 sets A, B and C. So U is a universal set. Universal set is the set containing all the elements of the sets under consideration. Universal set is the set containing all the sets under consideration. Disjoint sets. Disjoint sets are defined as 2 or more sets are said to be disjoint if they have no common elements. For example, A equal to set 1, 2, 3, B equal to set 4, 5, 6. We can see that the set A and set B have no common elements. So, the set A and set B are disjoint. Thank you.